this lesson for the future purpose, and also to share with you what we are going to study today. Okay, so today we are going to look at pressure in fluids, but this is a subsection of pressure. You should know that pressure in fluids is quite different from the pressure in solids. As we looked at last time, we looked at pressure in solids, and we also looked at pressure in fluids. Now, we also looked at some of the principle, which is known as the Pascal's principle. And we said that pressure in an enclosed vessel, pressure of a fluid in an enclosed vessel is equally transmitted in all directions, is transmitted equally throughout the liquid, or is transmitted equally in all directions of that liquid. So that's what we were looking at last time, the Pascal's principle. Pascal's principle, it is something that you should always remember. How would you state Pascal's principle? You should remember how to state it. Pascal's principle. Let's fix this camera. Okay. So Pascal's principle of pressure. Remember that, and we say that that principle states that pressure of a fluid, in an enclosed, the fluid must be in an enclosed vessel, is transmitted equally throughout the fluid. So the main thing here we should know is that the vessel must be enclosed, and we are talking about pressure of a fluid, not pressure of a liquid, but we are talking about pressure of a fluid. Then the other thing is we are talking about that this pressure is transmitted equally throughout the fluid. So you should know those two things, that it is the fluid that we are talking about, and that fluid is in an enclosed vessel, in an enclosed vessel. So we looked at the applications of the Pascal's transmission of pressure. One of them was the hydraulic machines. We looked at the hydraulic press is one of them, and we came up with a formula. Let me zoom this in and you can see. So we came up with a formula, and we say that if you want to determine the force that is on one side, which force is applied, which is called the effort, and the force which is applied this side is what we call the load. So if you want to lift a load of, say, force F2, you apply a force this side in form of the effort, which is F1. So the smaller force that you apply on this other side, will cause a pressure, and that pressure will be transmitted throughout this fluid, equally throughout this fluid to this other side. Now, that kind of pressure that you apply will make this load to move upwards. So it means that the pressure that is applied on this other left side is the same pressure that is absorbed, or that is applied on this, that is exerted on this piston on the right hand side. So pressure on both sides will be equal. And if pressure on both sides is equal, remember, if we say that this side was A and this side was B, so we came up with a formula, and we say that pressure at A is equal to pressure at B. So if this side where we have F2 is B and where we have F1 is A, then it means that how would you find pressure? It is the force divided by the area. Even this side, it is the force divided by the area. So one might not. You see, ones transparent. So in this case here, we are looking at pressure, which is at force F1. So we shall look at the force F1 here on the side of, on the left-hand side. We shall use F1 as the force. So we shall have F1 over the area here. We can call this side also area A1 equals to the force, which is this side, which is F2 over the area, which is this side, which is A2. So this is the kind of formula that you should know that you can use for you to determine the force which is on this other side or the force which is on this other side. If the other information is given to you, the information, like if they ask you to find F2, then you should be able to have A2, A1, and F1. If they're asking you to find F1, they should be able to have A1, F2, and A2. But the other thing that you should remember is that we know that area, this is a piston, and this area, A1, or the area, or let me call it just area. This area is of a circle. So we use the area of a circle, which is given by area is equal to pi r squared. So that's the area that we use. If at all we are to find the area A1, then area A1 will be given as pi r squared. Okay, then A2 can be equal to pi capital R squared. Okay, pi capital R squared, because I'm using capital R for A2 because at A2, this side, this is where we have the bigger piston, and A1, this side, this is where we have the smaller piston. So A1 is for the smaller piston and A2 is for the bigger piston. Now, you should know that you can be asked to, so this is the formula which is here that we can use if at all we want to solve any calculations. The other thing, what you can do is to just find the pressure this side and afterwards use that pressure and you find the force which is this side. Also, that is another way how you can do it. So let us go through these examples in just like 15 minutes and then we can proceed with other things under the Pascal's transmission. So number 2 here, we are going to use this formula which is here in our calculations. So number 2 is saying that if you look at number 2 is saying that a hydraulic press requires an effort. So a hydraulic press requires an effort. So we write the effort requires an effort of 100 newtons. So remember that when you're looking at the hydraulic press, this side where we have the effort, this side where we have the effort is the side where we have F1. So where we have the effort, this is the side where we have F1. So we can first read through the question very well and we get to know. A hydraulic press requires an effort of 100 newtons acting on a piston of area. So area of the smaller piston, area of small piston is equal to 20 centimeters squared. To press a bar of cotton placed on a piston of area. So there is another piston here. So area of bigger piston. So the area of the bigger piston is 240 centimeters squared. You can see this is small and this is big. Okay, where we have a bigger piston, that's where we are going to have the load, or that's where we're going to have the force F2. So they're asking if the percentage efficiency of the press is 80%, calculate the force applied on the barrel. So they have told you that the efficiency of the barrel is efficiency of the press is given as 80%. So what are they asking for? They're asking you to find to find the force of the barrel. Yes, the force applied on the barrel. So it's the force applied on the barrel, of cotton. So they're asking you to find that force that is applied on the barrel of cotton. So I want you to remember very well that the pressure that is applied this side is the pressure that is transmitted this side. And for us to use this formula here, we use this formula, we assume that the hydraulic press is working at 100%. So if the hydraulic press is working at 100%, then we can use this formula here. So let us see what if the hydraulic press is not working at 100% and they have said it is working at 80%. What would be the value of F2? What would be the value of F2? Okay, so members, are you there?
Yes.
Yes, I did not get time to first look through your names. Phyllis, good morning. Everyone, good morning. I can see Bazai, she's here. Finally, she connected. Mimi, who's called Mimi?
Me.
Who's called Mimi than me?
Drileba.
Hey, this is Dwereba. Dwereba, you are the one there. Oh, Dwereba, how are you?
Yeah. Fine.
You're fine. Okay.
Yes.
That is great. That is great. All right. So let us look at this question here and see what we are supposed to do. So if the hydraulic press is going to work at 80%, that means that we shall have 80 out of 100. 80 out of 100. So it is not working at 100%. Its efficiency is not at 100%, but it is at 80%. Is at 80%. So what we are going to do is we have to what we are going to do is that we are going to use this formula of F1 over A1 equals to F2 over A2. Now you should know that our F1 that we need, our F1 is 100 newtons. Our A1 is 20 centimeters squared. Our A2 is 240 centimeters squared. But then our F2 is not given. So it is unknown. It is unknown. F2 is unknown. So what we do is that now what we are going to do is that here we can do the cross multiplication like this, and we have F1 out of F2 will be equal to A1 over A2. I don't know whether you can see that. If I bring F2 this side, this is like cross multiplying. I can bring F2 here and A1 goes this side. Are we together? I bring F2 here and A1 goes this side. So that's what I've done here. This is what is done here. All together. And now what we are going to do is that we have to multiply this value which is here by the 80 out of 100, such that now if we are to find the value, because it is not at 100%, it is at 80%. So we divide 80 by 100. Now, what we are going to do is that we have to find this F2, because F2 is the force which is on the barrel. So by substituting F1, which is 100, F1 is 100, and F2, which is unknown, will be equal to A1, which is 20 out of 240, then times 8 out of 10, because this and this, you get 8 out of 10. So it means that now what we are going to do is that we have to find the value of F2 here. So we can say that 100 out of F2 is equal to, if you multiply 20 times 8, you get 160 out of 240 times 10, you get 2,400. Okay, now what we are going to do here is we are going to cross multiply, and we shall have F2 times 160 equals to 100 times 2400, like that, 2400. Are we together? So are we together, members?
Yes.
Yes.
So when we
Yes.
divide by 160, okay, by 160, we can divide by 160, and we shall have F2 is equal to, okay, this is 0, can go with this, and we shall remain with 100 times 240 out of 16, like that. So what do you get as F2? If you use your calculator, what do you get as F2 there? Use your calculator.
1,050.
You get what? 1,000 what? You get 1,500?
1,500.
Yes, you get 1,500 newtons. So what you should know is that if the hydraulic press is working at 100%, then it means that we shall have this formula: F1 over A1 is equal to F2 over A2. And this time we shall have 100 over 100, which is 1. But since here it is working at 80%, so we shall have F1 over F2 is equal to A1 over A2 times 80 over 100. Why? Because it is working at 80%. So there must be some kind of forces that made this hydraulic machine not to work at 100%. Forces like maybe friction, such resistant forces are the ones that normally make machines not to work at 100%. So if it is working at 80%, have to multiply it by 80 over 100. 80 over 100. Now, the other thing that you have to know is that we are going to look at more questions here under this exercise. We are going to look at more questions, and then we shall be able to calculate out more things. The other thing that you should know is that there is one advantage of a hydraulic press is that a smaller force that is applied is used to overcome a larger load. So a smaller force that is applied on a smaller piston overcomes a larger load. You have seen cars being lifted up using those hydraulic press machines, so that you cannot lift a car. The car is very enormous, and it's very big, and it's very heavy. So they just use a smaller force, but with the help of a hydraulic press, and the car is lifted up. So this is what we are seeing here. This is what we call the hydraulic lift. If you don't know other applications of the Pascal's principle, then I think you can add on another one, which is the hydraulic what? Hydraulic lift, which is used to lift up cars, especially when they are being worked on in garages. So they are saying that this is commonly used in garages, and it lifts cars so that the repairs and service on them can be done easily underneath the car. The force that is applied on a smaller piston, so this is the smaller piston here. There is a smaller force that is applied on a smaller piston, raises the large piston where the car is seated, which lifts the car. So they're saying that one valve allows the liquid to pass from Okay, this valve here, they are talking about that. This valve allows the liquid to pass into this other chamber here where we have the smaller piston, A. So this valve here allows the liquid to enter. So the smaller piston on uh, the, they're saying that's the small cylinder. I think there was some mistake here. Okay, what you should know is that here we have the small cylinder here and the larger cylinder here. The larger cylinder here acts as the reservoir. So the first valve here will allow the oil to enter through this valve to the smaller cylinder here. Now, once force is applied on this piston A, once a force is applied on piston A, what will happen is that this valve which is here will close, but this valve which is here will open. Why will it open? Because there is a pressure that is applied through this fluid, and this pressure that is applied will be exerted on this valve. So this valve will open because of the pressure that is exerted on it through the fluid, and the fluid they are using is oil. So normally it is oil that is used. So the pressure through this oil forces the valve to open. Now that oil will be pushed through the second cylinder, this larger cylinder where we have the bigger piston B, and this will push the piston upwards. So once the force is applied on the piston, closes this other valve on the left and opens the valve on the right, allowing the liquid to flow to the larger cylinder. Once the pressure inside the fluid forces the piston to raise up, and this will make the car to rise up. So that is what we call the hydraulic press, or I mean the hydraulic lift, which also uses the principle of Pascal's transmission of pressure in fluids. Then the other application that we have is what we call the hydraulic brake. And the hydraulic brake, this one you have already seen it. I know you have seen cars, and cars, whenever they are moving very fast, they have to stop. Now I want to show you something here, and then you understand, before we go through these notes, you understand very well how this hydraulic brake works. So let me see this was hydraulic brake system. Okay, let me see this. Of course, we are not into Jumia, but you want to see exactly. So this is the hydraulic brake, but before I show you this one, I want to show you something. That one, the previous video did not have, okay. So this is the one that you have in your books. This one here, it's like the one that you have in your books. So this hydraulic brake system has got what we call the brake pedal. This is the brake pedal, which is here. So when a force is applied here, normally I've seen people when they're driving, they have to press on that pedal. And once that pedal is pressed, here there is a hinge. So this pedal can move inwards, and it pushes this piston. So the force will be applied on this piston, which is here. And once the force is applied on the piston, inside here, we have got what we call brake fluid, and brake fluid is in the master cylinder. So this is what we call the master cylinder. This one here is the master cylinder. So the brake fluid, normally it is reddish in color, and once the piston is, we are going to say once the piston is pressed inwards, so the brake fluid will travel through this rubber tubbing or through this tube. Then it will reach it will reach into this what we call the brake shoe. So we have the brake shoe here. And you should know that here we have also two pistons. We have this piston and this piston, which is here. So the force that is applied on this pedal pushes the brake fluid through the rubber tubbing into this chamber. Now, how do we call this chamber which is here? How do we call that chamber which is here? So when this liquid reaches in this chamber is connected to the two pistons, and these two pistons are connected to the brake pads or the brake shoes. Now the brake shoe is connected to the wheel of the car, this one which is colored in blue. So this pushes, the piston pushes the brake pads and they touch the wheel, and the wheel will be able to stop. So this is what we call the hydraulic brake system, but I want to show you the animated video where we have the tire moving and the pedal is, the force is applied on the pedal, forcing the brake fluid into the rubber tubbing, and then forces the brake pads to touch the wheel and the tire stops. So let us look at that video and then we'll see exactly. Okay. Now this is what we call the master cylinder here, and this is the piston. Remember this piston, that this point here, this is the piston which is here. So the piston, and this is the master cylinder. So when you look at this, this is the master cylinder, and in yellow, this is the brake fluid. So let us see. So these cylinders are made in such a way that air does not enter, because air is compressible. So when the force is applied, you can see that I can take that, you can take that, you can take that again, and you see. Okay, so when the force is applied, the pressure that is transmitted throughout this fluid will force these two pistons, this and this. And these two pistons are connected to what we call the brake pads. These are what we call the brake pads or the brake shoe. Now, these brake pads, what they will do is that they will touch the wheel of the tire. This the one which is colored in brown is what we call the wheel of the tire, this one. So if the wheel of the tire is in rotation, it is moving, and now a force is applied on the piston, this brake shoe will touch the wheel, and now the wheel will stop moving. So at that point, the tire stops rotating and the car comes to a stop. Now, what will happen is that once the person removed the foot from the pedal, what will happen is that this brake fluid will go back to the master cylinder. So it goes back to the master cylinder once the pedal is removed. Okay. What else do I have to show you here? Let's see. Okay, not that, not that. I think I've showed you Pascal's principle. There is nothing much, yeah. Yeah, I think I've showed you the Pascal's principle. That's how it works. And I don't know whether you have any question there, but you should know that the car to come to a stop, you don't need to you don't need to apply a lot of force on that pedal on that brake pedal because it is just a smaller force that is needed. We have seen that when you're looking also at a hydraulic press, when you're applying a force on the effort, it is just a smaller force that is used on that piston where we have the effort. So even here on the brake pedal, you just use a smaller force. Otherwise, if you use a larger force, the car can come to a stop suddenly, and then this may cause accident. Someone behind you may collide with you. So what you have to do is that you just have to apply a smaller force on the brake pedal. Once a smaller force is applied on the brake pedal, it will force the brake fluid through the rubber tubbing into the sleeve. Okay, this is what we call the slave cylinder, and inside the slave cylinder, that's where we have the two pistons. So the two pistons will apply a force on the brake shoe. It's what we call the brake shoe, and the brake shoe touches the brake drum or the wheel of the car, and the car comes to a stop. So you should know that the system of the brake system of the car is made in such a way that all the tires have this kind of system. In most cars, all the tires have this kind of system. So one force that is applied on the pedal pushes the liquid through all those other tires to all those other tires. That's why we are seeing that we have this arrow showing that to other wheels. So there are 4 wheels on the car. So the brake fluid will be pushed to all those other tires, but using a smaller force that is applied on the pedal, and this will push the brake fluid through this rubber tubbing. And once the brake fluid reaches the slave cylinder, it pushes the pistons, and those pistons touch the brake shoe, and the brake shoe will make the wheel to come to a stop. So that is the hydraulic brake system. So in your notes here, they are saying that when the brake pedal is pressed, this should be pressed, not placed, is pressed, the pressure exerted inside the master cylinder is transmitted equally to all the slave cylinders. So the slave cylinders, they are 4 because the car has 4 wheels. So the pressure that is applied in the master cylinder is transmitted through the brake fluid to other slave cylinders. Now, at the slave cylinder, the pressure acts on the pistons which are connected to the brake shoes. So that the pressure acts on the piston which are connected to the brake what? Which are connected to the brake shoes. This is what I showed you here. Yeah, these are the brake shoes. So these are the 2 pistons. So the pressure inside that fluid, once it is applied, it touches. So the fluid, once it moves inside, pushes these pistons, and they touch the wheel. So this is what we call the brake shoes, and this is what we call the wheel. And the car will come to a stop. That's what I told you, or I showed you. So they are saying that this presses the brake shoe against the brake drum or the disc or the wheel, hence creating a friction which opposes the rotation of the drum and therefore the wheel. This results in the stopping of the car. Okay, members, are you there? Do you have any question about the hydraulic brake system before we proceed to our numbers of calculations? Vanita, do you have any question?
Shall I do they use the red fluid?
Why do they use the brake what?
The red fluid.
Why do they use the red fluid? Now, that red fluid is what we call the brake fluid, the brake fluid. In most cases, that brake fluid, they use it in those cars. The reason is that it is a liquid, it is a fluid, and it is in form of oil. So you know that oil, oil cannot be mixed with air. In other words, you cannot have air in oil because air is compressible. So the reason why they use the oil which is the brake fluid, is that the brake fluid is incompressible. It is incompressible. And because it is in form of oil, so it will not it will prevent the friction between the piston and the master cylinder, because whenever the piston is moving inwards or outwards, it has to move within the master cylinder. So what they have to do is they have to use oil, because we know that oil is one of the things that we use to reduce on friction. So that's why they use brake fluid. That's why they use brake fluid. They don't use water, because we know that water cannot reduce friction, but we know that oil can reduce on friction within this master cylinder and the piston. So that's why they use brake fluid. Brake fluid is incompressible. That's the reason number one. And also the other reason is that because it is oil in nature, it reduces on the friction within the master cylinder. All right, another question. Another question. Letitia Paula. This is Lamono. Do you have any question?
No.
Okay. Have you understood?
Yes.
Okay. So what we are going to do is that when, I don't know what time it is, but when we come back, we shall be writing a few notes about this brake system, and also we shall go through the calculations, these calculations which are here.